Hello everyone, my name is Chinmay. I am from ECEB. My roll number is 20BQ1A0469. Now I am going to explain about a surface area and characterization of nanomaterials. There are three types. I am explaining on only two types, that is a scanning electron microscope and a transmission electron microscope. Transmission and scanning electron microscope. First discuss about the transmission electron microscope. Transmission electron microscope will be in this way: electron gun and anode and condenser lens and a Spiceman and objective lens and intermediate lens and a projectile lens and the fluorescent screen. Transmission electron microscope has a Spiceman which is which is less than 0.6 nanometers or 100 nanometers or 3 millimeters. Spiceman is fixed on a support grid embedded in a resin or stained with a particular compound, a uranyl acetate and osmium tetroxide stain embedded in epoxy resin. Transmission electron microscope principle: the electrons which are transmitted through the specimen or sample which will give image of this specimen. When cathode ray has the pass electrons with high resolution, that is high energetic beam of electrons are passed through the cathode ray, then it will be projected to the condenser lens and it will transfer from condenser lens to the sample or specimen. The thickness of sample is less than, I already discussed, less than 100 nanometers. From specimen, the electrons are transmitted through the objective lens and by projector lens it will project the image or electrons to the fluorescent screen. Description: let us consider a cathode ray gun which is the source of highly energetic beam of electrons. The electron beam is concentrated by condenser lens. These concentrated beam of electrons are allowed to pass through a sample or specimen. These transmitted electrons from the sample are corrected by the objective lens and guided towards the fluorescent screen by using projected lens. These transmitted electrons will give the image of specimen on fluorescent screen. TEM applications are structure of specimen, surface area of specimen, chemical composition of this specimen, properties of this specimen. Here the whole sample will be analyzed. Working of TEM. The specimen is bombarded by a beam of electrons. The primary electrons, the bombarding electrons are focused to bundle onto the object. In areas in the object where these electrons encounter atoms with a heavy atomic nucleus, they rebound. In regions where the material consists of lighter atoms, the electrons are able to pass through. The fine pattern of electrons leaving the object reaches the objective lens, forms the image. It is then greatly enlarged by the projector lens. Eventually, the transferring electrons reach the scintillator plate and at the base of the column of the microscope. The scintillator contains phosphor compounds that can absorb energy of the striking electrons and convert it into light flashes. Thus, a contrasted image is formed on this plate. Next, scanning electron microscopy. A scanning electron microscopy will be in this way. Here, this is the specimen and the, the electron gun, that is cathode electron gun, and next the anode and magnetic lenses, and there are scanning coils and the projector lens, and next the surface area. Principle: scattered electrons will give the image of the specimen. When cathode ray gun has in when we pass the source as a narrow beam of electrons, then cathode ray will passes through the beam pass through the condenser lens and next objective lens and get scattered at the sample or specimen. The scattered electrons will get reflected in two ways, that is one by bad scattered electrons and scattered electrons. One is primary electrons and that is secondary electrons, and scanner electrons will get reflected on the computer monitor. Description: let us consider a cathode ray gun which is the source for narrow beam of electrons. These electrons are concentrated by using condenser lens and allowed to pass through a objective lens. Finally, these electrons are incidented on a sample. Then two types of electrons are ejected: scattered and backscattered electrons. These scattered electrons are scanned and will give the 3D image of the specimen on a computer screen. Some applications: structure of specimen, surface area of the specimen, chemical composition of the specimen, properties of the specimen. The electron gun produces an electron beam when tungsten wire is heated by current. This beam is accelerated by the anode. The beam travels through the electromagnetic fields and lenses, which focuses the beam down toward the sample. A mechanism of deflection coils enables to guide the beam so that it scans the surface of the sample in a rectangular frame. When the beam touches the surface of the sample, it produces secondary electrons, backscattered electrons, and X-rays. The emitted secondary electrons are collected by SED and converted into signal that is sent into a screen which produces final image. Additional detectors collect these X-rays, backscattered electrons, and produce corresponding images. Differences between SEM and TEM. Electron beam passes through thin sample, whereas in SEM, electron beam scans over surface of the sample. Specially prepared thin samples are supported on TEM grids. Sample can be any thickness and is mounted on an aluminum stub. Specimen stays halfway down column. Specimen stays in the chamber of the bottom of the column. Image shows on fluorescent screen in TEM, whereas in SEM, the image shown on the TV monitor. Image is a two-dimensional projection of sample, whereas in SEM, image is of the surface of the sample. Thank you.